Hey everybody, this is Tech Teach again. We're still looking at Class 1 levers, and we've talked about F of E times D of E equals F of R times D of R. Got a new picture up here. The fulcrum is now 6 feet from the end of the teeter-totter in both directions. On one side of the teeter-totter we've got a 60-pound force going down. On the other side of the teeter-totter we've got a 40-pound force going down. So you can kind of look at it and tell what it's going to do. Since the distances are the same and the only thing that's different is the forces, the person who weighs 60 pounds is going to go down and the person who weighs 40 pounds is going to go up with a difference of 20. But as an engineer, we got to be able to prove that. So we use this formula, F of E times D of E equals F of R times D of R. So if you take all of the numbers that are above and put them below, you get 60 pounds times 6 feet equals 40 pounds times 6 feet. So if you multiply that out, you get on one side of the equation 360 pounds. On the other side of the equation, you get 240 pounds. So the difference there is 120 foot-pounds. And so if you could say it's 20 feet, 20 pounds for every foot of length difference. So what does that really mean? And how can we use that in calculations for figuring out mechanical advantage things? Well, if this person was 60 pounds and this person was 60 pounds and both of these lengths were the same, 6 feet, it would be said of it that it was in static equilibrium. Both of these forces would be the same. Well, there's several ways we can do that. We can increase the pounds of force to be equal to the pounds of force over here, or we could manipulate this moment. Now a moment is a force times a distance, and in this case it's from the fulcrum over to the right side is the moment of resistance, because we have F of R and D of R over here on the right side. Over on the left side of the equation we have F of E times D of E, so this would be the moment of effort. So if we can manipulate the numbers and we can make this equation on this side, 60 times 6, equal to this side of the equation, we would be in what we call equilibrium. So let's see if we can do that. What could we do to make this different? We already said one thing we could do is we could put 60 pounds over here. 60 times 6 would equal 6 times 60. So we could do that really easily. Or what else could we do? Maybe we could adjust this to equal 360. So what times 40 is equal to 360? So if we extended this and made it 9 feet, then 4 times 9 is 36. 40 times 90 is 360. So if we made this 9 feet, then we would be in static equilibrium, wouldn't we? Because 360 foot-pounds is equal to 360 foot-pounds. So that's one way of using this to calculate and estimate if we change the length or we change the force so that they're equal to each other and set it to static equilibrium. In the next lesson, we're going to actually use static equilibrium to calculate a length and then calculate a force that we don't know. So good luck. I hope you got this lesson. If you didn't, rewind, watch it again and again. I'll see you in the next lesson. Check out my website, tech-teach.com.